Hi everybody, this video topic is designing for building functions, and what we're going to talk about is how the shape of the structure helps aid in the function of the building or the use of the building. So first we're going to start talking about what's called the building envelope, and it's this area here that's been highlighted in red, and it's the perimeter of the structure. So the floors, the walls, the roof, the doors. The envelope essentially encloses and shelters the space and creates a barrier for rain and protects from the sun and wind and harsh temperatures. And traditionally, we had seen this building envelope as a static entity, meaning that it didn't interact with anything. It was for mere protection. But today, designers and architects see the building envelope as a more dynamic boundary, meaning that it allows the inside of the building to interact with the outside. So it keeps the rain away, but maybe it also gathers rain and uses it to water the landscaping. It keeps harsh temperatures out from the sun, but maybe it collects solar energy and transfers that to the electrical needs of the structure or of the building. So the building envelope is no longer just a static entity. It serves many different purposes. This building in Beijing is a great example of how the building envelope creates this dynamic relationship. This is the SIEEB, Solar Energy Efficiency Building in Beijing. And there are several features here that create this dynamic approach. First of all, the facade opens towards the south and provides these stepped exposures that focus on a central courtyard. And above these patio areas or these terraces, there's photovoltaic arrays that shade the terraces while capturing solar energy. On the east and west side of the building, they have these double glass facades with horizontal sunshades to create an exposed surface to collect the sun, but also to prevent the sun from entering the structure when it's strongest on the east or west. And also, there are pivoting glass louvers that have reflective coating on the exterior walls in the courtyard area to help regulate daylight and solar gain. The northern exposure is heavily insulated and mostly opaque to shield against cold winter winds. The orientation of the building and its width and height determine how the building will be shielded from excess heat or cold and open to ventilation or light. The Flatiron Building is a great example of building form allowing for building function. This site is famous for its pie shape, and it was built this way because the actual lot that it sits on was pie-shaped itself. Back in the days of the early skyscrapers, architects had to figure out a way to get light and air into all parts of the building because there wasn't electrical cooling or lighting at the time. The Chicago window was one of those innovations. First of all, it had a large glass area, or large for the time, that allowed a maximum amount of light to enter the building. And then in addition, it had this operable aspect where an inhabitant could open it and then allow ventilation. And having these windows on all sides of the structure allowed for cross ventilation. So if you're ever in a house and you open a window on the east side and you also open a window on the west side, maybe you hear doors slam. That's because the air is being sort of passed very quickly from one side of the house to the other. And that's how the earliest tall buildings were ventilated. Another great example of building form supporting building function are hotels near the beach, or this one in Dubai. It's shaped in such a way so that it allows as many terrace suites as possible and gives all of the rooms a really great view of the sea. The bubble diagram is an example of how a designer or architect begins creating the building form. Spaces with similar needs are grouped together. For example, areas that need public access will be located perhaps on the ground level, whereas mechanical areas and things that aren't used by the public may be placed more towards the center of the building and on higher floors. In addition to access or proximity, some spaces may need to take advantage of daylighting and views and natural ventilation. So perhaps you consider conference rooms, waiting areas, and executive offices maybe need window space, whereas lower level employees could perhaps be in the center of the building. Things like copy rooms and break rooms perhaps could be more in the center of the building. Larger structures are separated into two zones. The perimeter zone, which runs along the outside and touches the exterior or the building envelope, and the interior zone, which is more protected. Typically, the perimeter zone will be more difficult to heat, and the interior zone will be more difficult to cool. Oftentimes, HVAC system engineers will separate these two zones so that the temperature can be regulated individually. The space between the floor and the ceiling below is called a plenum. The purpose of the space is to move air through air ducts and house electrical wiring, plumbing like sprinkler heads and fire protection and other important functions of a building. The interior design aspect of this, and where you're going to be concerned, is oftentimes you have a light fixture that you want to place and maybe it's in conflict with the width of the duct. You'll have to know how much space you have in the plenum to put your light fixture before you can specify specific fixtures. In most multi-story buildings, the stairs, elevators, toilet rooms, supply closets, mechanical, plumbing, electrical chases are all grouped together in something called a service core. Here you can see in this floor plan, the service core is placed in the center of the structure. There are various types of building cores. A single core placed in the center is nice because it allows pretty quick access. Even if you're all the way over here, to get to the stairs or the bathroom, you don't have to go very far. Now, the drawback is it creates some narrower spaces here on the sides and is more difficult to design around. Putting the core at the edge, like you see in the image below, allows for more open floor space, but the drawback is that this guy over here, he's going to have a longer distance to travel. And also, it's taking up some valuable window exposure here. When you have long horizontal buildings, oftentimes you're going to put more than one service core because having a core over here is really difficult for the people on the opposite side of the building and vice versa. So multiple cores are often used in very long, lower buildings. The last type of core is called a detached core, and you can see that here in this building in Chicago. Now, the benefit of a detached core is it's not taking up any of your floor space, so you've got a lot more rentable area. But of course, the downside then is, you have maybe more distance to travel or longer service runs. So that's it for this section on designing for building functions. Be sure to watch the next video on the human body and the built environment.